questions at the end of the presentation. Also, this webinar is being recorded for later use, and I'll be sending out a link to the recording afterwards. So let's get started. The first question you might be asking yourself is, what is StepSERVO? Let me answer that question with this diagram. This diagram in this slide shows a typical open loop step motor system. Starting from the left, we have the input that is supplied to the drive controller. This input will often come from a PLC, a PC, a motion controller, or some other controls on the machine. The drive controller is the electronic amplifier that powers the step motor, controlling its torque, speed, and position. The output of the step motor is, of course, the rotor position or the shaft position, which connects to the mechanical components of the machine. Another diagram that you are likely familiar with is the closed loop motor and drive system. To the open loop system, we add a sensor, which in this case is an optical incremental encoder, which provides torque, speed, and position feedback to the drive controller. One important thing to point out in this diagram is that the feedback loop created by the drive, step motor, and sensor is controlled by a conventional PID servo control algorithm. This important detail, along with all of the benefits of having a PID servo control loop, is what defines these step motor systems as StepSERVO systems. StepSERVO technology can really be applied to any step motor system. However, at Applied Motion, we have decided to offer this technology first in an integrated package. This slide shows the same system diagram we were just looking at, but arranged in a slightly different way to highlight how these elements fit into an all-in-one integrated motor. As you can see from the bullets on this slide, the StepSERVO integrated motor is comprised of a 50-pole brushless motor, also known as a step motor, a 5,000 line incremental encoder, which gives us 20,000 quadrature counts per revolution, integrated drive and control electronics, and the closed loop PID servo control that I already mentioned. Now, let's look at some of the benefits of StepSERVO. First of all, a traditional open loop step motor system is a little like driving a car with a blindfold on. You can point the car at the destination, and you can figure out how much you'll need to apply the gas and brake pedals to get there. But once you've calculated your trajectory and started moving forward, there's no way to compensate for changes in direction along the way. On the other hand, using StepSERVO removes this blindfold and allows the motor drive system to compensate in real time for changes in the load that might happen along the trajectory of motion. This simple difference greatly increases system accuracy and ensures that the target position is reached. This slide shows a typical speed torque curve for a step motor system. As you can see in this chart, there's only one torque range available. The torque range is commonly referred to as dynamic or pull-out torque and is somewhat analogous to continuous torque in a closed-loop servo system. As you can see in the StepSERVO speed torque curve on the right, a benefit of operating a step motor with closed-loop control is that a second peak torque range becomes available, as indicated by the orange line. This peak torque range offers up to 50% more than the continuous torque range of an open-loop system. Now, you may note that the peak torque range is not available over the entire speed range of the motor, but this is the nature of 50-pole brushless motors. The torque of a step motor is highest at low speeds and tapers off as the speed increases. The benefit of StepSERVO is the higher peak torque available in this low speed range, where the advantages of step motor systems are well established. Another benefit of StepSERVO is its ability to handle a variety of load conditions. In a traditional open loop system, if the torque demand from the machine exceeds the torque available from the step motor, the step motor will stall. In other words, it will stop running and not reach the target velocity or position. In a StepSERVO system, the closed-loop control algorithm will deal with this high torque demand by increasing motor torque up to the peak torque limit. So again, this peak torque range of the StepSERVO ensures higher system accuracy, that the step motor will continue to run instead of stalling, and an overall increase in system reliability. The final benefit I'll mention here, and which is one of my personal favorites, is related to motor heating. Because open loop step motor systems don't regulate motor current based on torque demand, they run at full current regardless of load. Essentially, this ensures that step motors will run at elevated temperatures. And if you're used to working with step motors, I'm sure you're already familiar with the common phrase, quote unquote, step motors run hot. Well, this is just the nature of the beast. Because step motors run at full current regardless of load, they run hot. StepSERVO solves this problem with step motors by proportionally controlling motor current to the torque demand. In other words, current draw from the motor is proportional to the load. If the load is light, the motor draws less current. This dynamic current control allows the step motor to run much cooler than in open loop systems. Said another way, step motors no longer run hot. Now that you know the benefits of StepSERVO, let's look at the product offering from Applied Motion. As I mentioned earlier, StepSERVO technology is first being offered in our line of integrated motors. There are 3 types or flavors of StepSERVO motor currently being offered, and they're called TSM, SSM, and TXM. It's important to note that the differences between these 3 types are only in the details. All of these integrated StepSERVO motors use the same high-resolution encoder, the same PID current control loop. They're available in different NEMA frame sizes with various COM port options, and they're powered with DC supply voltages. So those are the similarities. Now let's look at some of the differences in the details. Starting with the TSM StepSERVO. This integrated motor accepts DC input voltages up to 70 volts DC. It's available with an RS-232 or an RS-485 serial port. It has 8 digital inputs, 4 digital outputs, and 1 analog input. It comes with the following control modes: step and direction, analog velocity, streaming commands, stored program execution, and field bus options, including CAN open and Modbus. And it's available in NEMA 17 and 23 frame sizes. The SSM has the same DC input voltages up to 70 volts. Instead of a serial port, you get an Ethernet port. It has slightly fewer I/O than the TSM. It has 3 digital inputs, 1 digital output, 1 analog input. It's really intended for streaming commands, stored program execution, or Ethernet IP field bus. And it comes in a NEMA 23 frame size. And then the third type is the TXM. Again, same input voltages up to 70 volts DC. You can get it with any of the COM port options, 232, 485, or Ethernet. It has the same I/O as the SSM, so it's got 3 digital inputs, 1 digital output, 1 analog input. It can do all the control modes, from step and direction all the way up to the field bus options of CAN open, Ethernet IP, Modbus. It comes in a NEMA 24 frame size. If you're not familiar with this designation, it's basically a 60 millimeter frame, so it's a little bit larger than a NEMA 23, and it also has a little bit more torque than the NEMA 23. And the biggest differentiator with the TXM is that it's rated IP65. So it's good for use in wet and dusty environments. It can be used in the splash zone where water is going to be splashing on it, or coolant, or oil. It has M12 connectors to support that. Additionally, all of the component pieces like the end bells and the drive cover are sealed during assembly, and there is a shaft seal on the front shaft. If you're interested in IP65, we have an excellent video on our website showing these motors in action. This last slide shows a summary of the three types. There are the IP40, TXM, and SSM on the left in the green box. You can see the frame sizes that are available with those two, as well as the COM port options that are available. The IP65 rated TXM is on the right in the blue box. Again, you can see the frame sizes and the COM port options available there. So really the first choice you need to make in selecting one of these motors is what IP rating do you need? Is it going to be in a clean, dry environment or a dirty environment? And then go from there. And the yellow box at the bottom of this slide shows that all the control options are available in all the types, whether it's step and direction, velocity, streaming commands, stored program, or field bus. You can get the different options in any one of the, between the two different types, IP40 and IP65. So I hope you enjoyed this free webinar, which introduced you to the benefits of the new StepSERVO integrated motors from Applied Motion. Additional information on StepSERVO can be found on our website. Thank you again for attending. At this time, I'll open up the webinar for questions. Please use the chat tool in the webinar control panel to submit your questions, and I'll stay on the line as long as needed to answer them. Okay, we got one question here. Are these in stock? Yes, these are in stock. Every one of the types that we've talked about here today are available for immediate shipment. They're on our shelf in California. You can go to our website, place an order there, get units sent to you typically same day. They'll ship from our factory if the order is placed by the afternoon. Have another question about the analog input, 4 to 20 and 0 to 10. The inputs are rated on these are rated for 0 to 5 volts. If you have a 4 to 20 milliamp or a 10 volt signal, you'll have to do some signal conditioning to get it into the 0 to 5 volt range accepted by the motor. Another question about larger frame size. So we have, will these be available in larger frame sizes? So as I mentioned, we currently have the NEMA 24 is our largest one, which is essentially 60 millimeter. We will have a NEMA 34 sometime in the future. We don't have a specific date on that yet, but that is in development now. And that will probably be the biggest version that we offer, the NEMA 34. I have a question here. Is this webinar available online? Yes, I'm recording it. I started the recording a few seconds late, but all the meat is in there, and I'll send out an email afterwards with a link to the recording of the webinar, so you can watch it whenever you'd like. Are there demos available to distributors? Yes. Distributors, please contact your sales manager in your region. If you're in Georgia, that would be the Southeast region for Applied Motion. Your contact is Dennis Joyce. He can get you a demo. Another question, will we have AC power? Right now, our path forward is primarily DC power. This is a hot topic of discussion, particularly in the larger frame sizes. If the person who asked this question, if you'd like to follow up with me afterwards, if you have some specific thoughts about AC versus DC, I'd love to hear them. The one issue with AC is you've got a lot of additional capacitance that you have to put inside the package. And so what used to be a nice compact package, drive package on the back of the motor now suddenly gets quite large. You still get some nice integrated motor benefits like less cabling, fewer components to put in your control panel, and if it's IP65 rated, now your power supply is also IP65 rated because it's included inside the motor. But again, the limiting factor there is how big do we want to make that integrated package on the back of the motor. We've got another question here about encoder outputs. Do these motors come with encoder outputs? Yes, certain models that are specifically designed for step and direction control, where you would typically be using them with a third-party motion controller, those we provide encoder outputs back so that you can feed the encoder signals back to the motion controller and have a closed loop performance up at the motion control level as well. So those are on certain units in the TXM family that are designed specifically for step and direction control. And the encoder outputs are quadrature, so you get A+, A-, B+, B-, as well as an index channel or a Z channel, plus and minus. These are great questions. If anyone has any more, please send them. And I'll hang out for another minute or two to make sure that all questions get answered. Got another question. Is software free on the website? Yes, thank you for asking that question. All of the setup and tuning software, because these are closed loop devices, they do require some tuning. That software is available for free on our website. If you go to our website and you look for these motors and you find a motor that you're interested in, it will have a link to the free software download. All of the tuning parameters for the motors and for different load inertia mismatches are included with the software. So tuning is very straightforward and simple. You just select the motor and then the amount of inertia that you have on load, which typically you're going to estimate as either 1x, 5x, or 10x, and then you can, it's a very simple download to the controller and you're done. I have a question about Ethernet IP. Have we tried it with a Rockwell PLC through Ethernet IP? Yes, we have application notes on our website for the Logix 5000 software, and we have add-on instructions available for Logix 5000. So if you want to use our StepSERVO integrated motors, or actually any of our motor drive products with Ethernet IP, we have support for compact Logix and control Logix through our add-on instructions. There is also the MicroLogix family also does have some limited Ethernet IP support. So that would be the Logix 500 software, and we do have an app note as well on that. So offering of application notes to help you with that. App notes for Omron and Mitsubishi PLCs. At the moment, we do not offer app notes specifically for Omron or Mitsubishi PLCs, but we do have people in our company with experience with those PLCs. For example, one of our sales engineers here in the Chicago area is very familiar with the Mitsubishi PLCs. So if you have an application that is going to be using one of those PLCs and Ethernet IP, we'll be able to support you. We've actually I got a great team of application engineers at Applied Motion. All of them have a lot of years of experience and with a wide variety of applications. So I encourage you to give us a call and talk to our applications engineering team if you have any additional questions. But I'm going to stick around here as long as needed and answer any more questions that might come up. Got one question about additional system accessories. What power supplies do you have available? We offer 24 and 48 volt power supplies on our website that are specifically for use with these integrated steppers, as well as our other standalone drives and motors. We also offer planetary gear heads for all of our motors. So we have NEMA 17, NEMA 23 planetary gear heads that fit right on the front of the motors. You get if you really want to increase the torque of the axis. We also offer all necessary mating cables for these motors. For example, I/O cables, communication cables, those are all available with the motors. In fact, most of the motors come with a programming cable in the box, but if you need I/O cables, for example, we sell those as accessories. Those ship separately from the motor and have to be ordered separately. All right, thanks again for these questions. They're really good. If you have any more, please send them my way. I'll hang on for another minute or so to see if we get any more questions. All right, well, I think that about does it for the questions. Thank you, everybody, again, for attending and for sticking around to listen to the question and answer section of this webinar. Like I said, I'll be sending a follow-up email with a link to the recorded webinar, as well as some links to our website with additional information. Please keep your email inboxes open. We're hoping to do more of these webinars in the future. And thank you again. I wish you an excellent day.